before going to discuss this topic, we have to know what is the purpose of the error control coding. So in analog communication, there are so many noises in analog communication. So we have to avoid that noise. So that is what we have moved to the digital communication. Suppose if we want to transmit a data, automatically the noise gets added. So in digital communication, 0 may be changed to 1 or 1s may be changed to 0. So this causes the various types of the noise. So we have to detect the noise. So for that, we are going for one of the technique which is nothing but the error control technique. So in this error control technique, we are having two methods. One is error detection, another one will be your error correction methods. So in error detection, we are going to detect only the errors. We are not correcting the errors. But in case of the error correction, we are detecting the errors as well as we are correcting the errors. So here we are having so many error control coding techniques. For example, if we have taken the linear block codes, convolutional codes, Reed-Solomon codes, so these are all the types of the codes which prevent the errors. So we are going to detect that errors. Suppose if we want to, we are using the mobile communication or space communication. Suppose if we want to write in a CD, whatever it may be, we are using in the form of digital. So for that purpose, we have to detect all the errors. For that, we are going for this error control coding.
So, as Ma'am said, we have many error control codings, and one of the major application of using this error control coding is in space, that is while communicating between the space satellites or rovers with ground control rooms. So basically the challenge lies between high latency, high distortion as well as difficulty in demodulating signals. So space companies like NASA or ISRO uses advanced coding techniques like Reed-Solomon or LDPC. So these LDPC and Reed-Solomon bring most advantage while giving in error control coding. And also recently we know that Chandrayaan-3 Mars rover has been failed due to the error control coding. Because of that we lost signal, and due to which the rover crashed at the last minute. So by using these coding in most advanced way, these rovers carry all these informations basically. So using these informations, using these coding, the ground control will control entire rover as well as satellites, and it gives more accurate information to the ground control.
So next we can discuss about the role of error control in 5G wireless communication. As in today's world 5G communication is growing up, so the error control plays a very important role in 5G communication to ensure and check that it has an high reliability and data integrity despite of precision of noise data and interfacing of fading communication and wireless channels. So based on this, nowadays a new radio that uses an LVPC, that is known as low density party checker, is nowadays used, that replaces the old turbo version that is used in 4G. So the role of LDPC, that is low density party checker, is used in error correction because it produces an excellent result in error correction codes that is used in 5G wireless communication. So together these low density party checker code and this byte error code compares both the integration and checks whether there is an reduced in bit error. So after this, this will be an communication system is useful. So with this togetherness, they will ensure that there is a seamless connectivity, and it may also used in autonomous vehicles and in IoTs and in telecommunication 5G broadband communication also.
So I'm going to share about the role of error control coding in memory storage devices. So before the invention of error control coding, many of the technicians were used as floppy disk for their memory storage devices. So it can hold up to maximum 1 kilobyte. So after the invention of error control coding, Now the lifespan and accuracy of memory storage devices have been improved longly. For example, we can see the application of error control coding in a solid state drive, which can hold up to the memory around 10 years. So it is comparatively an improvement from the existing memory storage devices like floppy disk, etc.
So in error detection and correction in IoT sensor networks, it mainly focuses on lightweight ECG algorithms for low power IoT sensor nodes. So it features like a trade-off between reliability and power consumption and real-time correction in wireless network sensors. So the examples like ECC in ZigBee or LoRa-based systems.
So I'm going to share about the role of ECC in satellite communication as well as networking. So after the invention of error control coding, many of the satellites uses the principle to detect and monitor the space movements such as planetary motion as well as to mapping the extraterrestrial bodies as well as to understand the physical and geographical condition of the planets. So widely it has been plays a significant role in lately known as the Event Horizon Telescope. So it uses the error control coding principle to analyze the data of black hole. By the analysis of error control coding of that black hole, they have organized around 1 terabytes files of black hole images, and co-jointly they have connected and produced an output of the first ever black hole image in 2019. So error control coding plays a crucial role in today's modern digital communication, etc.
So now you got an idea of why we are doing for the error